let's talk about the final project in this course. It's an important aspect of the course, and we'll be covering it for the last couple units here. So I pulled it off as a separate folder here, and it'll be, if you're in the new learning management system, you'll also see a separate folder there. Um, so the final project gives you an opportunity to kind of research and dive a little more deeply into some area of machine learning that we've covered in the class and work on it. So I want you to investigate and describe a topic in machine learning, examine some of the current literature related to that topic, and then state some position or hypothesis that you'll be testing out, and then test this out in a Colab notebook or a Kaggle notebook, something like that. Often you can take something that we've done in class and build on that here. So we do want you to be doing some research with actual peer-reviewed journals. So you can use like the Library Solar Energy or Google Scholar to do some to find some actual peer-reviewed journals. For this, you need at least 2 academic peer-reviewed journals to cite it here, and then you can have additional websites also, or resources you find here. Here's a basic outline of your paper. You do a quick introduction, do a quick literature review where you just discuss, do a summary of one or two of the papers that you've found that you're looking at. And then you're stating your position. Now, there are kind of 3 options you can do for this final project. One is you can do an hypothesis with some data. If you have your own data, like in your own company, you can use that and make a hypothesis and try to do a prediction on that. So maybe you have customer websites for a commerce website at your company. So maybe you want to hypothesize that the frequency and how long students spend, or customers spend on a website, can be used to predict how much a customer will spend in the future. So in the last month, if a customer spent so much time here, you can predict hopefully how much that customer will spend in the next month or something like that. You'd have to set some parameters there of what you might want to. So again, if you have your own data, you can predict something related to that. If you're using data that's out there, like maybe you don't have easy access to your own company's data or wherever you're at, you can then use data that we've used in the course, data from a Kaggle challenge or something like that, and then you can hypothesize something related to machine learning. So for example, there's this new thing called spatial dropout 2D layers in convolutional neural networks. So maybe you're going to be working with this new challenge we're doing this week with pancreatic cancer and Kaggle. So maybe your thing would be that using spatial dropout 2D layers in a scene is better than traditional dropout layers for combating overfitting in this sort of image processing situation. And so you test that out. You test out normal dropout layers, and you test out these new spatial dropout layers. Now there's a third option. In a perfect world, I think we'd all be doing these third option, and that's where you'd be doing a combination. You'd have your own data, and then you'd be hypothesizing about that. And so maybe you'd say this type of machine learning model is best, provides the best answers to your data set. So maybe you would say something like that. A deep learning neural network will outperform a support vector machine model when predicting customer late payments. So maybe you have a system, you have some data on when customers are paying their bills late. And then you're testing out 2 different neural networks, two different machine learning models, and saying which one of those is going to work best given your data set. So again, you have to choose one of these 3 options, trying to give you a little flexibility on what to do for that. And then again, hopefully you'll create a simple model and describe how you set up the model, analyze your results, and hopefully you'll have some hypothesis here, and you can explain, did your results confirm that hypothesis or not for that, and then just a conclusion. So that's kind of your layout of it. Now, in order to get you started on this, I want you to create a final paper idea assignment first, or a final paper summary or outline here. So here's the link to that. And again, I'm just taking the outline that we had here with these sections and saying, well, let's just have you start writing the initial paragraph. So write a one paragraph introduction, and do a little literature review and write some background on the topic you're researching. What is it? A paragraph on that. Are you using your own data? What data do you want to use? And write a paragraph on that. And then again, hopefully you have two key sources. These do not have to be peer reviewed yet. Just find two sources that would be this. So for example, if you are working with this second option and working on some new area of neural networks or some area in the class we've covered, you could do some search on the spatial dropout 2Ds layers and just cite two websites or two places where those are described here. So I want you to start thinking of ideas now. I'd like you, hopefully you can talk to me and we can brainstorm ideas. Feel free to call, text me. I have lots of time over the next couple of weeks, and I see a lot of these different papers we can and ideas, so I can help you brainstorm different ideas here. I do have a document here that outlines some of the ideas. So again, these are the three options. The first option is using your own data here. So some things, do you have regression data that is labeled so something that's nice sometimes, regression data where you're just predicting some number. So maybe what's likelihood of a student dropping out of college, or can you predict the budget spending or the time delay on supply shipments based on something. So yeah, again, if there's some number in your data that you can use to predict, that's really helpful, and we can do a regression model on that. Similarly, for classification, do you want to classify your data? Now, again, with classification, we need some pre-trained models generally, so we need to have these all already categorized. So maybe you have customers, and you bill them in your small business, and some of them pay right away, and some of them you have to send reminders and stuff like that. And so you're just trying to predict how quickly. So rather than doing this as regression, what you're going to do is group your customers into maybe three categories based on how long it takes them to pay their bills, and then use that to predict new customers. And can you predict what class they're going to fall in? So again, with this classification problem, it's really nice to have some sort of we need some sort of predefined categories this data falls into. And so is that part of this? Now, if you don't have that, you could look at clustering, where you were just, you have a bunch of data about customers and you want to just try and group your customers together or things like that. We have limited ways of doing that, but we can certainly do that. Another thing kind of related to regression here is time series prediction. We'll be getting to this in the next unit. And that said, if you have a series of events or numbers that come one right after another, you can train a model to predict what the next one is. So like commonly this is done with stock prices. So if you know a set of stock prices, you can try to predict what the next week's price for that stock is going to be based on the past history of that. You could also look at things like, in a sporting competition, can you predict how a player will perform based on past performance areas? So we can look at something like that. So again, if you're working with your own data, start thinking of that. Another option is just to investigate some different models we've looked at. We've looked at support vector machines, decision trees. We've talked about dimensional reductions with PCA. We've done clustering with k-means clusterings. We've done a number of neural networks, basic neural networks and convolutional neural networks. And next week we'll be doing long short-term memory, which will be handling time sequences. Here. And so you could apply these to some data set that we've already covered in class. look at a Kaggle competition or Kaggle data sets out there. There are also some other data sets that are out there. And so if you talk to me about this, we can hopefully come up with some idea of a data set and something like that. So. Another thing is, if you're interested, you could study one of the newer machine learning topics. And so here's just some links to some machine learning topics that are out there. And I will update that because I just noticed now that these are a lot of 2018, 2019 ones. So I'll update this with the newest versions of these. So. So if you're just stuck here, some different ideas of this, maybe we'll be looking at these colorizing black and white photos. There's this salt channel, challenge within Kaggle. That we can do more with the whale IDs. In particular, the best solution with the humpback whale challenge in Kaggle was something called Siamese networks. So maybe you want to read about Siamese networks and compare those to traditional neural networks and describe why they seem to work better with the humpback whale challenge in Kaggle here. There are different Google challenges out there, so you can look at, and we can talk about different ideas for this. Now, one thing to consider with this challenge or this final project is with the master's degree, you also have to do a final applied project, and some students find it useful to link their final applied project with this, the final project in this course. I believe in your final applied project for the master's program, you have to do 4 different types of analysis, and you can certainly use this as the part of the predictive analysis where you're trying to predict something and analyze that. So again, feel free to talk to me or Brandon Olson about tying this project in with your final project. So the final project for this course could also be used as a stepping stone for the final project for your whole master's program. So I'd really like to talk to each of you about this. Hopefully you can call, text me. We can set up a Zoom or whatever to go over this, brainstorm ideas. I have lots of time over the next few weeks to work with you each individually on this. So please get a hold of me and we can discuss some options.